Hey there guys, welcome to this video. My name is Pushpinder Gill, and in this video we're going to be talking about vector algebra in two dimensions. Right, so we're going to be talking about vector algebra in two dimensions. So what is the purpose of this video? The purpose of this video is to show you how to add or subtract or multiply vectors algebraically, and also how to show them in a geometrical form. Let's say, for example, I have two vectors. Let's say, for example, I have a vector A, which is 1, 3, and I have a vector B, which is 2 and 2. Now, if I want to represent this vector A geometrically, so how will I show that? So let's suppose if I have the axis here, right? So let's say this is the x-axis and this is the y-axis. So first thing is you can choose any point as origin, okay? You can choose any point as your origin. So let's say, for example, I choose this point. Let's say 1, 1 as my origin. Any point, that doesn't matter. Okay. Now, if you choose any point as the origin, now what you have to do is that, let's suppose that point is x1, x2. Right. So in this case, our point is 1, 1. Now what you have to do is that your vector will go from x1 plus a and x2 plus b, provided that the vector is ab. So what you're going to do is you're going to say that your vector is going to go from x1 plus a to x2 plus b, provided that your vector is ab. So if this is 1, 3, that means your new vector will actually go from, since your x1 and x2 are 1, they go from 1 plus 1 till 1 plus 3. That means the destination of your vector would be 2, 4. So what is going to be the destination of your vector? The destination of your vector is going to be 2, 4. So it's going to be 1 and 2. Fine. And then it's going to be 0, 1, 2, 3, 4. So this is going to be the destination of your vector. Fine. So that means you can actually draw your vector from here till here and in a direction like this. So this is how you represent this vector over here, right? So let's suppose you want to define vector. So this is how you do it. Let's suppose you want to define vector 2, 2. Now if I want to define vector 2, 2, how would I represent? Let's suppose I say that 2, 4 is my origin. So what's going to happen? Where is going to be my destination? If 2, 4 is my origin, the new vector is going to be 2 plus 2 plus 4 plus 2, which is actually going to be equal to 4 and 6. That means it's going to go from 1, 2, 3, 4 and 1, 2, 3, 4, 5 and 6. That means it's actually going to go till here. That means this is going to be my vector B. So if this is going to be my vector A, this is going to be my vector B, what is going to be my vector A plus B? A plus B is actually going to be this vector right here, isn't it? So A plus B is actually going to be this vector right here, and you know that this is 4, 6, and you know this is 1, 1. So if I have to find the vector A plus B, what I can do is I can actually subtract, that is 4 minus 1 and 6 minus 1. Now why do I do that? Because from 1, 1 I'm going till 4, 6. That means this represents my vector over here, that is this vector. So that means this is going to be equal to 3 and 5. And as you can see that if I literally add 1 and 3 and 2 and 2, I will actually get 3 and 5. So that's how I can say that if you have a vector A with these coordinates and if you have a vector B with these coordinates, vector A plus B will actually be simply the addition of the individual vectors. Let me explain what I just said here, okay? So first I said that if you want to geometrically represent a vector, so what you do is you choose any point as the origin. Let's suppose that point is x1 and x2. In this case, let's suppose I chose point 1, 1. Now, you want to represent vector 1, 1, 3. So what you have to do is go 1 away from this and go 3 away from this. That means your vector goes till 2, 4. So what you do is you draw till 2, 4. Then after that, how do I represent vector 2? So I chose this as the origin because I want to use the triangle rule to find the resultant vector. So I chose this as the origin, and from there I went 2 forward and 2 forward. What did I get? I got 4, 6. then the resultant vector is going to be this vector according to the triangle rule or the parallelogram rule. So from here I can say that if the origin is 4 comma 6 and if the origin is 1 comma 1 and the destination is 4 comma 6, that means the resultant is going to be 4 minus 1 and 6 minus 1, which is 3 comma 5. That means I can say that if there is a vector A with, let's say there's a vector u with a comma b, and there is a vector v with c comma d, then vector u plus v is simply going to be equal to a plus c and b plus d. Fine. So that is how this is going to be. That is the addition of two vectors. So this is how I say that this is the addition of two vectors. So I hope that is fine with you guys. I hope you've understood this point. Okay. Now let's move forward to the next part. That is the scalar multiplication of vectors. So what do you mean by scalar multiplication of vectors? So let's say, for example, if I have a vector, let's say I have a vector u, which is a and b. If I multiply a scalar number with the vector, so that means what's going to happen? Each number is going to get multiplied by that scalar number. Let's say, for example, if I have a vector a, let's say I have a vector u, which is 1 comma 2. How does 1 comma 2 represent? So 1 comma 2, I'm actually going to take 1 comma 1 as the origin. So 1 comma 2 would be 1 plus 1, which is 2, and 1 plus 2 is going to be 3. So this is going to be my vector u. Now if I multiply, let's say, number 2 along with it, let's suppose if I want to find the value of 2u, that is going to be 2 times 1 and 2, that is going to be equal to 2 and 4. So this vector is actually going to be equal to 2 times 4. That is going to be the value of 2u. Okay, so I hope you're able to understand my point over here. So this is going to be the value of 2u, that is 2 comma 4. I have to multiply 2 along with it. And if I want to show that geometrically, I can actually pick up any point. Let's say I pick up this point, that is x is equal to 1, x is equal to 4, y is equal to 1. So if I pick up this point, what do I have to do is I have to go 2 up. So this is going to go 2 up, that is 4 and 2, 6. And this is going to go 2 to the right and 4 to the top. So 1 plus 4 is going to be 5. So this is going to be equal to 2u, which is going to be double the magnitude and parallel to this vector. Fine. So I hope you're able to understand my point over here. Let's say, for example, if I have a question, let's suppose if I have a vector a that is actually equal to 1 and 2. So what is going to be 2 times a? 2 times a, it's simply going to be 2 comma 4. I'm going to multiply 2 along with it. What is going to be 3 times a? 3 times a is simply going to be equal to 3 comma 6. I'm going to multiply 3 along with it. What is going to be equal to negative a? Now negative a is going to be negative 1 and negative 2. And understand, geometrically, if this is vector a, then this is going to be vector minus a. It's going to have the same magnitude, but it's going to have an opposite direction. Fine. So hope you're able to understand this point over here, guys. Right? So that's there. Right? So let's move forward. And also understand that vector addition is going to be commutative. So vector addition is something that we've already established, that vector addition is going to be commutative. What do you mean by that? That means that vector u plus vector v is going to be vector v plus vector u. So if I have to add a and b and c and d, that would be equivalent to adding c and d and then adding a and b. Fine. So I hope that's fine as well, guys. Right? So that's okay. Let's move forward to the next part. Now what I want to do is I'm actually want to talk about the zero vector. Now what's a zero vector? A zero vector is of a vector 0 comma 0, right? It's actually just a point. So it's a zero vector, and understand that if I multiply the zero vector, so the addition of a vector and its opposite vector is also always going to give you a zero vector. right? So that is something which is always there. So I hope that all is fine, guys. I hope you're able to understand what I'm trying to say here. And this is known as the opposite vector. Just want to clarify that. This is known as the opposite vector of this vector. Because if, let's suppose I have a vector A with C and D, and I have a vector B which is negative C and negative D. So I can say that B is the opposite of A and the vice versa as well. Fine. So I hope that's fine, guys. I hope you're able to understand my point here. So thank you very much for watching this video, guys. So we're just building up the base right here. So I hope you're able to understand what I'm trying to say. So there are going to be future videos on vectors for sure, where we're going to be discussing everything that, that the vectors have. So this would be our Facebook page where you can give us your valuable like, and this would be our our web address where you can explore more about us, and this would be our email address where you can give us your valuable feedback. So thank you very much for this video, for watching this video, guys, and I'll see you in the next one. Cheers.